All right, here's what we're going to do. Would you all agree that this is R? Now, would you all agree that the, the rectangular figure is a square? It actually says the word square as well. So it's definitely a square. Now, what I'm taking is that all four of these angles are the same size. That's 90, that's 90, 90, 90. It means I'm now using right angle triangles. You cool with that? So I have an idea. Here's going to be my idea. Actually, we have a half base times height. Because it's a right angle triangle, you're allowed to use a half base times height. Or you can use a half AB sine C, or you can use a half base by height. Now, guess what? I'm just getting the area of this triangle here. Does everybody see this triangle here? Everybody see the area of that blue triangle? How are we going to get that? That's going to be a half R times R sine. And sine 90 is actually the number one. So it's just a half. And if I use a half base by height, the base could be R, and then the height could also be R. So it'll just be a half R as well. Do you see the way it didn't matter which way I did it? I was getting a half R squared no matter what. Now, here's the difficult part. What you guys are going to need to do now is we have the area of the what's called the triangle. What you guys need to find out now is the area of the pizza slice here. See that pizza slice here? Anybody have any ideas how to get the area of that? Area, not length. A quarter of a circle. How did he know it's quarter of a circle? Yeah. So it's going to be a quarter pi r squared, yeah? So the answer for the shaded part is a quarter pi r squared. Take away what? Take away the area of the triangle, which is a half r squared, and you're done. That's it. In terms of r, I think the first problem is that 2 pi over 3. That's radians. Why don't we just change it back into degrees? So what's pi again? 180. 2 times 180 divided by 3? That is 120 degrees, which in turn will make this one here 60. Okay. Would you all agree that who said isosceles? Good man, whoever said it. Why is it isosceles? They're both radiuses, aren't they? Now, it does say in radians, to be fair to it, right? Now, here's what we're going to do. It's 60 degrees, but when you go to your tables on page 13, sorry, yeah, it is actually 13, just got ripped out. That was it there? 60 is actually pi over 3. So you can just change it back into pi over 3 really quickly. Now, find the exact length of the perimeter of the shaded portion. The perimeter of, sorry, find the exact length of the perimeter of the shaded portion. I think we're just looking for this part here, aren't we? See that green part? It's a different color. See the way it's all blue bar that part? Sorry. Do you know what it is? I think the whole blue section is the shaded part. Or green. Alright. So I have an idea. Is there anything in the course that will tell us what the length of the green line is? There's a trigonometry formula that will do that for you. Anybody know it? Am I allowed to use Pythagoras' theorem? Sine rule or cosine rule? Cosine rule is what you use when there's a sandwich. See the two sides sandwiching in the angle? So what we're going to say is the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay. X squared equals what, guys? Yeah. Plus. Yeah. Yeah. 60. Lads, will you lob all that into the calculator for me and tell me what it is? Make sure you're in degrees. All right. 4 on the money. So that's 4. And then do a square root of it. So it's 2 as well. Oh, so we didn't actually have to say equilateral. Oh, so we didn't actually have to do that. Thank you. Sorry, guys. I should have twigged that that's an isosceles, which therefore makes an equilateral, which therefore means all three sides are 2. And the good thing is, even though I didn't see that, I still have the cosine rule to prove it to me, which is good. See the two radiuses are 2 and 2. So that means that'll be angle x and angle x. And because there's only 120 left, it's divided by 2, which is 60. Okay, so believe it or not, we did not need the cosine rule whatsoever, but it's nice to know that we could use it. Okay, next thing, we have the green length. Now, we have this red length, don't we? Okay, so what we need is we need the red length. The red length plus the green length is what, lads? Yeah, it's 4 plus 6, isn't it? Now, what's the next length I need? It's currently black, but I'm just going to color it purple now. See that purple length? Anybody know how to get that? It's 2 pi r, yeah. And what fraction of the full circle do I have? 120 degrees, which is 120 divided by 360, which is what you said. It's 1/3 of the full thing. And what is r again? 2. So 2 pi times 2, what's that? So that's 4 pi, yeah? And it's multiplied by 1/3, yeah? 4 pi over 3, otherwise known as 4.19. So that's your 4.19 plus the 6 we were talking about earlier, wasn't it? So that's 10.19. You all good with that? Okay. Centimeters. Okay. Now what's the area? Lads, any idea how you do the area? You could try that. Full area minus the part that's not shaded. That's I would do it in 2 parts. I'll show you the way I might try and do it. I'd do it like this. I would do the area of the pizza slice. Oh, sorry, terrible color. I'd do the area of the pizza slice. Can anybody tell me how to get the area of the pizza slice, the yellow part? How'd you get the area of the yellow part? I'm talking about the yellow part, which hasn't got a triangle in it. Yeah, it's 1/3 pi r squared. It's 1/3 of the entire circle. No, it's 120 degrees. You're still looking at the 60 degrees. I'm looking at the 120 degrees. I'm looking at the yellow section. So it's 1/3, which is 120 over 360, right? And then the area of the full triangle is pi r squared, right? Which is pi times. Now, throw all that in the calculator. What do I get? What you get? 4.19. It's 4 over 3 pi. Is it 4.19? Or 4 over 3 pi? Press the change button. 1/8, rounded up. 19. There we go. Okay, guys. Does everybody see the triangle? How'd you get the area of that then? Huh? That blue one there. No need to do half base by high. Yeah, do a half 2 sine 60. See the way it's a half, it's a equilateral, so you can do a half 2 sine 60. What you get for that? Huh? Plus root 3. All right. 4.19 plus root 3 then. 5.92. Now, guys, guess what they want now? They want the area of the little, see this green region here? They want that. Anybody tell me how to do that then? Half the area of the large circle, take away 5.92. So what's the area of the large circle then? No, it's a half the large circle, which is pi r, squared. What's the radius of the large circle? 2, isn't it? So the radius of the large circle is 2. So do a half pi times 2 squared. And what does that come out to be? 2 pi, which is in 6.28, take away your 5.92. 0.036. We're expecting it to be small, aren't we?